I've been worked in visualization for a very long time at this point. I think I started around 1997. This was in the days when it was database visualization was the big thing. So I cut my teeth on a system called VASS, which was developed at the University of Wisconsin by, amongst others, Roger Ramakrishnan, who's a very well-known database person. The thing about VASS is that it had a back-end database engine for range queries that was very powerful. But one of the things that made it special was the ability to coordinate multiple views in a way that was very high performance. So you could connect up different plots of data and maps of data and so on, and do things like synchronously scroll the views, filter one set of views on others, and define some powerful queries. And this was very early on in being able to do that. And as a result of that, I got very interested in the idea of composing visualizations and providing tools to help people build composed visualizations, coordinated multiple view visualizations that support powerful querying capabilities. And just in the last few years, we've really started to see an explosion both in the InfoVis community, the VASS community, and to some extent the SciVis community as well, of tools that are designed to support more sophisticated querying by composing multiple different visual representations and interactions. Right? So in a sense, I've been seeing, from my perspective, a lot of people in these other communities actually starting to do work that I actually think of as being very much in VASS, about providing tools for overall analytic process. Now, for me, I've been doing it for a long time. Even though I started off in the natural sciences, I was actually trained as a chemist and a mathematician. Over the years, I've come around to enjoying the humanities as an application domain for visualization quite a bit more. And part of the reason for that is that the data is so darn interesting. It's complicated, it's rich, it's hard to interpret. In many ways, it's related to the kind of data sets that we're often interested in visual analytics, intelligence analysis, business intelligence, and so on. Because it's so complicated, because there's detective work that's involved. Let's see if I can fix that. My visualizations are dynamic, but they're not supposed to be that dynamic. So I often like to give a spiel like that as a qualifier, because people sometimes ask me, why is humanities interesting? Right? For a lot of us, we come at things from the harder side, in a sense, right? Quantitative data, and a lot of visualization techniques are designed for quantitative data. But how do we help people support analytic processes when a large part of it is about the qualitative information in data and the reasoning that one does with the nuggets of information that one has to assemble it, to describe some sort of reasoning process to motivate conclusions and hypotheses. And these things are actually much more qualitative in nature, even if the original data is quantitative in nature. So I think the humanities is actually a very good area to work in if you want to focus on these later processes of reasoning. You don't kind of have the crutch of numbers and the easier representation of numbers visually to lean on so much. How are we doing? Do I just need to not touch it too much? Or talk? All right. Let's try the other adapter. So in the last couple of years, I've been working almost exclusively with domain experts in the humanities. So I work with folks in classics. These are people who reconstruct Latin texts that are long lost. They're from 2,000 years ago. There are fragmentary copies that have been copied multiple times for over 2,000 years. And there's a long history of classic scholars trying to reassemble what the original might look like. So this is kind of some deep text visualization. yeah, so that's an example of one project. So for me, the big question is, how do we go beyond just interacting to navigate in our data and browse to actually be able to express our observations about the world? Right? In the case of humanities, it's often through deep reading. We're looking at a collection of texts, sometimes physical artifacts, and other documents. But one of the things that humanities scholars do is they assemble a narrative. It's basically their line of reasoning and the story that they tell to assemble sparse nuggets of information. It's not too unlike what, say, an intelligence analyst might do to take their shoebox full of information and try to perform sense-making on it. In fact, the analogy is, I think, fairly strong. I'm sorry about this. I'm not sure what the hardware issue is.
I think it's our end, not yours. Capturing okay, but not presenting.
I see. And this looks very much like a loose cable.
It does. But,
Oh, we don't think it's the laptop. Oh. My focus is on interaction rather than representation. I do work on new representation techniques as well, but I'm really interested in how we can help people to express their questions, which is one of the things that we think about, right? Which actually happens cognitively, through interaction. To be able to, as a person, how do I know how to translate the questions that I want to ask of the data into actual queries, and how do I compose the individual interactions that a visualization might support in order to put together those queries. So I spend a lot of time working on interaction. It's coming. Okay. I see two of them here.
Yeah.
Just flip that around.
This is my vision. It's medium gray, right, which is kind of appropriate for visual analytics in a way. Nuanced reasoning, hypotheses about what might appear on the screen if something were to happen.
Thanks for the warm-up. The problem is,
you rebooted something. Okay.
well, the touchscreen doesn't have a sort of "Are you sure?" kind of menu thing. So when you accidentally with your little finger touch the projector off button because it's a touchscreen, you turn the projector off. So, and then even if you turn it straight back on again, it still has to go through some really long
warming cycle.
process.
Yeah.
My apologies.
So I didn't intentionally intend to slow fade in, but let's work with that. So my vision for kind of a comprehensive desktop for humanities research looks something like this. There's the essential coffee, and of course this has got an analog feel to it. With humanities scholarship, there's a lot of time spent with deep reading. This is the primary material that people work with. So can we provide tools that allow people to engage with the material not only at the level of individual data items, but the structure overall? And can we engage with the data through the visualization itself? And I mean more than just browsing. A lot of what scholars do is they take their observations from the deep reading that they do, and they assemble data sets. And it's pretty amazing. I know a fair number of humanities scholars at this point. They all use Excel, and they all build ad hoc, very large spreadsheets to try to organize their data. And they have no data modeling expertise whatsoever. So they come up with these chimera, these hodgepodges of information in which the data can evolve from this column to this column, and I look at it from somebody who's experienced with data modeling, and it's horrific, really. How many artifacts might be sneaking in to the spreadsheets that they're building? So part of what I want to be able to do is to provide visualization tools that kind of take that issue away, right? To allow people to interact, to express their data, to actually build relationships in the data, that express their observations and their reasoning, but do it directly through the visual form of the visualizations itself. And I'll come back to give you some examples of that. In fact, I'm hoping I can get you to all think through and maybe invent some examples as well. So I like to think of analytics broadly, and visual analytics as well, as the next general purpose methodological science. Right? We have math, and we have statistics, and these are broadly applicable in just about every domain. I would argue that analytics is the third one. It's a general purpose case. We focus on visual analytics, but I actually argue that there's an element in visual in just about every kind of analytics in one form or another. We have interactive visualization as well. It's the face of analytics. The visualization lets us share our ideas about data, and interaction helps us to express those ideas and to browse through those ideas. For me, it doesn't matter whether the data is small or large, whether it's simple or complex, whether it's quantitative or qualitative. There are people working in all sorts of different fields. The data that they have is important to them. Right? Yes, we have big data sets. They're the marquee data sets that a lot of people are interested in, but there's a very long tail of data of great importance to scholars and practitioners in many, many fields. You can make an argument that the vast majority of data sets, and important ones, are qualitative, complex, and small. Is it interesting and useful for human understanding? For me, that's what really matters. So for us, visual analytics research is focusing on more and more, and we can see this at the VASS conference, and at InfoVis as well, data that's more deeply textured in a way, that has a lot more structure to it, right? We're trying to start to get at harder problems of understanding data that more comprehensively and completely models whatever natural, social, or built system we happen to be looking at. And the question for me is, how can interactive visualization support a comprehensive digital workspace, in my case, focusing on humanities scholarship? And what that means is, let's try to find ways for our users to spend less time with intermediate tools, kind of stepping out of their process and going into the spreadsheet. Can we kind of keep them in the mode, right? That's that image of the desktop where they have their materials and they have their analytic tools, and can they kind of stay in the zone, as it were. So let's spend some time talking about interaction. I'd like to build up to the vision that I have by going back a little bit in time and talking about the things that I've developed for interaction over the last couple of decades. One of the problems with visualizations is that designing interaction is actually quite hard. We've gotten pretty good at designing representations and incorporating them into tools, but interactions is an entirely different beast. Right? For the most part, the interactions that we have are relatively simple. We pan and zoom, we select some things, right? We scroll around, we've got some controls, right? Some widgets that we can twiddle to do things. There's, with some exceptions, and there are actually some people in the room working on the harder problem, like Alex. We don't have a lot of sophistication in the interaction. I actually equate it to, we have interactive grunts and clicks, right? We've got these beautiful representations where we're going, yeah, do something interesting, right? We lasso some stuff, we scroll some stuff around, but I mean, think about scrolling in a data space. It's like saying, you've got all these abilities to move as a human being in the room, but we're going to make you do this, right? Maybe this. Can we do something better? Well, okay. Here's part of the problem. People want cool and flashy and things that make their lives better, right? People say that they want interaction like that that's here. As visualization designers and visualization developers, what do we want people to want? All the bells and whistles, right? All the different features put together supposedly relatively cleanly. And this is how we develop our tools right now, right? Just throw in some more widgets and another view that will do some other things. And maybe if we get the right magical combination, it will actually let people express the questions against their data that they want to express. And we spend an extraordinary amount of time developing tools and writing papers about how we've mashed up the different bits and pieces, and then we try to evaluate them, either by just assessing the utility by reasoning or through usability evaluation to see whether it works or not. Now, what can we build today? It's kind of something like that, right? Soldering and glue, we throw things together and then perform on stage at conferences from time to time. Well, what do people actually need and what can they actually use? Well, of course, we want elegance, but also completeness for the particular purpose at hand. So let's have a look at kind of what happens in the complete life cycle of interaction within a visualization tool, particularly one that goes beyond just allowing you to merely browse, that actually allows you to build something. Right? Most of the visualization capabilities that we have typically involve two separate phases. Right? We could be talking about D3. We could be talking about the system I developed. We could be talking about other systems, predecessors to D3, like Prefuse and ProtoViz, or coming follow-ons to D3, like Vega, for instance. The building process tends to happen separately from the browsing process. And this is kind of unfortunate. Right? In the end, it's the users, the domain experts, who want to be able to figure out how to express their questions. But instead, we give them tools that have the capability to express certain questions by composing interactions. Right? And then we go through this cycle of talking to them, and they say, no, we actually want to be able to express this query, and we go off and we build something else and give it to them. We haven't kind of figured out how to integrate that cycle of letting people build their own ways of expressing things. Be it that as it may, there's a cycle of interaction that typically follows where you have users, and they express the questions that they have about their data by building queries through interaction. They execute the interaction in a set of views, and the views display the results to the users. Sometimes the users are the developers, or they talk to the developers in order to do design, and the developers then design in InfoViz and some visual analytics tools. This happens by composing a data transformation pipeline with source data at the beginning and a set of transformations. If you've got a sophisticated enough system, you can integrate interaction into the data transformation pipeline in a relatively flexible and easy way. But even if you don't, you can integrate interaction in an ad hoc way through regular old programming. And that often can happen in some other user interface as well, whether as a low-level language or as some high-level visual language or development environment of some sort. Now, there are two kinds of primary interaction that happen in most visualization tools. The first one you might call navigation. It's basically moving around in the space of data from the perspective of the views that you have. So if you have a scatter plot, you have a kind of like a two-dimensional camera focusing on two dimensions of the data. And if you have a table, in a way you can scroll over a coordinate system, which is the list of whatever set of data attributes happens to be shown in the table. Or if you have a graph view of something, you can kind of move around within the conceptual space of the entities and the relationships kind of being mapped into that bag. But each view kind of gives you a low-dimensional perspective on the full complexity of your data. So we navigate around in space. The other thing that we do is that we tend to interact with individual data items in some way. Right? Now, the thing is that most of that interaction we do for that purpose is selection. As a matter of fact, years and years ago, 97, Chris North and Ben Schneiderman wrote a paper that basically said that all visualization interaction is either navigation or selection. And that's not entirely true at this point. You should probably include annotation in there somewhere, and that's an important point that I'll come back to, is actually the part of the vision that I have. But for the most part, what you do is you select. Somehow the selection affects the filtering of things and the aggregation of things and the visual encoding of things in the pipeline, and you see objects highlighted in some way, or objects filtered, shown in a set of views. And so in a way, we have, whenever we're actually interacting with individual data items, we have the ability to kind of just turn items on and off. That's our ability to interact with individual items, for the most part. I want to present a vision of the ability to interact with items in a much deeper and richer way with individual objects, while still preserving the ability to move around spaces. Much of the design for information visualization happens in the data state model. This is a figure from one of Ed Shee's papers. He's someone who figured out that the data flow pipelines that are popular in scientific visualization tools can be readily transformed to and from a model of data state. That is the structure of a visualization seen based on a set of parameters. If you have a set of parameters, that kind of is where you are in the data space. And if you change one of the parameters for interaction, you move to a different point in the data space. Kind of abstractly. It really means just scrolling and selecting items. So the two models are equivalent. The thing is that it focuses very heavily on how to represent data. It doesn't really say anything about how do you interact with data. And in fact, there are relatively few systematic ways of integrating interaction into this pipeline. There are many, many ad hoc ways. Just about every visualization tool does, but there are relatively few systematic ways to do that. So that was the bulk of the work that I did during my dissertation and many years after that. In some ways, continue to do to build a system called Improvise, in which interaction is deeply infused into the data flow pipeline. So that you can have just about any of your data transformations, even data loading, data presentation, filtering, and so on, be a function of whatever interaction parameters that you care to include in your visualization design. And as a consequence, you can build coordinated multiple view systems with sometimes extreme sophistication, sometimes too much sophistication, right, with great complexity. And there is some question about whether or not you want to have your visualization tools have so much stuff in them. But what you can say for the tools you design in Improvise is that they let you express a lot of different questions against the data, and to do it with a great deal of flexibility if you can learn how to do that. So can we build visual analysis tools from such things? Let me show you a few examples. Some of them are pretty old at this point. This is an example of an ion cloud moving in 3 dimensions. It's chemistry/physics data from my time as a chemist many years ago. This is not meant to be a serious analysis tool, but rather just a tool that demonstrates many of the different ways that you can connect up different views interactively. So we have scatter plot matrices, and there's a parallel coordinate plot, and we've got a time slider where time has been mapped into color, and you can do things to filter some views on other views and couple the interaction. There are sets of interactions where you have a scatter plot matrix that shows X and Y and Z projections. The 3-dimensional one is up there. And then there's actually a cube in that space that you can kind of pick the cube that you want within another cube, right? This is not, as someone who actually studied this data many years ago, this is not a useful tool for actually studying the data, right? It is a good demonstration of all the interaction that you can build into some tools. And in fact, the language that you write in the improvised system to express all of these different views and the interconnections between them is actually quite simple. The system is built around declarative expressions. It's a declarative functional reactive programming language. So in some ways you can think of it as D3 for the desktop. It came many years before D3 and actually lets you do lots of interaction and build it. Right? So there are trade-offs there. Obviously D3 is great for building relatively simple interaction, but to embed them in web browsers and to be able to develop and do that pretty quickly. If you're kind of on the other end of the spectrum where you want sophisticated tools and lots of interaction, then you probably need to go to the desktop for performance reasons anyway, but you need a more sophisticated system to be able to assemble those things. What you can develop within Improvise is a set of visual encodings, a set of filters, a set of sorts, and a set of data loading operations built on declarative language statements like that. So for instance, this one here says in a particular plot of X versus Y, draw a set of ovals using the X and Y attributes of the data, fixed width and height, and then do something a little bit special for the fill color, which is to map a time parameter into a color gradient relative to the minimum and maximum values over the entire data set. And so something that's, a few things that are interesting that are happening here is that time gradient that's highlighted there, that's actually an interactive parameter of the system. You can dynamically change that, and the colors will change as a consequence. And so that provides the ability, for instance, to change the visual dynamic range of what it is that you're seeing without changing any of the rest of how the visualization works. Here's another case where, and it's a very similar statement, where one of the views is being filtered based on the range of time. And it's done perceptually, so you actually drag that range of time over the color gradient itself, and you see the corresponding range of colors being shown in a view. Here's another example. I put this together because there are thousands of interactive periodic tables out there on the web, and my own old interest in chemistry. And so I use this system to develop a very interactive version of the periodic table in which you can select which physical properties that you want to look at, see the actual layout of the periodic table adjusted, do dynamic filtering on different parts of the periodic table, and so on. Whether you're interested in that or not, there certainly is a lot of interaction going on in there. So, the system is based on a language called coordinated queries. And it's this idea of having your interactive parameters, whether it's a value associated with a slider or a particular color that you could pick interactively and so on. These are variables that you can connect to the individual widgets, to the plots, to graphs, to sliders, whatever they happen to be. And that way you can couple the views to each other. So for instance, to synchronously scroll them, or to have brushing happening because you can select a set of data items in one and see them highlighted in both. And you can actually select items in either one. It's really easy to wire up the different views together using this particular approach because the parameters have kind of been removed from to their own space. The controls are not directly wired to each other anymore. There's a level of indirection there that gives you greater flexibility in wiring things up. Moreover, if you see that beige hexagon there, you can have your statements that map the data into other data, that load data, that filter data, that figure out how to visually encode data into individual views. You can have those be arbitrary functions of whatever variables that you like. So you can have your queries be a function of whatever parameters and connect those parameters up to whatever views or widgets that you like. And as a consequence, you can build really sophisticated interaction into your tools. So here's something, this is a more recent visualization of international events reported in newswire feeds. There was a big project some years ago to compare human extracted versus machine extracted events from newswire feeds. Right? In the same way that, say, in intelligence or police reports, you might try to extract the entities and the movements, times, and the relationships and so on. There was a project to extract from newswire feeds, and this visualization lets you look at the geographic relationships, the calendar relationships between usually two actors that involve. So one state or a state group or an NGO is interacting with some other state group, for instance, and it was cooperative or it was conflictual. And this helps you see patterns of how those evolved over time. You can, for instance, in this case, I drilled down to Iran and Iraq, and I eventually drilled down to one particular reported event in 2002. You can use the system with sophisticated multidimensional querying to basically dissect what's going on in the data set. With the interaction capabilities, you can put together a lot of different, what I call coordination patterns. Right? In the same way that you have design patterns in software engineering to put together your different software components, the different views that you might see in a visualization can be assembled using different coordination patterns. So if you have two views that are synchronously scrolled with each other, or you're brushing across views, these are examples of some of the simpler patterns that you can build in the systems. And if you have enough interactive sophistication and the ability to wire things up, there are a variety of patterns that you can achieve. I'm not going to go through any of these in particular, just to give you a sense that there is some organization of the coordinated multiple view design space that you can draw upon, either through other examples or through principled capturing of patterns that people have already done. This is one that I quite like. This is a visualization of Major League Baseball games. There's a lovely online database called RetroSheet of baseball aficionados who basically transcribe the play-by-plays of all Major League Baseball games. There are about 2,500 per year, and their database now goes back into the 40s with the complete set, and incompletely back into the 19th century. This one is showing about 13 years of season data, so roughly 32,000 games. And you can focus on particular home or away teams, particular stadiums, look at the games in terms of their environmental conditions, whether it was sunny or cloudy during the night or during the day, the capacity of the stadium, and so on. One of the interesting things that's going on here is that if you look over on this side here, there are a variety of statistical aggregates calculated for each game, like the number of doubles or the number of strikeouts that happened by the away team or the home team in the game. There are dozens of statistical variables for each game. This visualization lets you pick two of those, see a bit of a scatter plot matrix that shows the date and the time of the game along with those two variables plotted against each other. You can pick ranges of the two that you want. So for instance, I've picked temperature and the capacity of the stadium there to kind of look at cases where the stadium was full and the temperature was very hot, and see whether that might have any particular effect on the game in some way. And then you can look at, for all of those games, what teams were playing, what time of day they tend to happen. And you can actually see that many of the games are actually more in the southern states, for instance. You can see the pattern of games and the calendar on which they happened. So there's a lot of multidimensional capability here, and it's all dynamic. So when this little variation filtering on checkbox is checked, as you're dragging around this box, everything else is dynamically updating and in the appropriate way. And so you can actually get what's sometimes called motion parallax, where you can actually see the result of the query changing over time and see the effect of your interaction. So for instance, if I increase that box to higher temperatures, I can see maybe the flow of the games in space or the flow of the games on the calendar changing, and try to get a sense of that change. As you start to build lots of visualizations that have these interactions in them, you can start to identify kind of like higher level patterns, good ways and general ways of organizing sets of views for visualizations of lots of different kinds of data sets. And cross-filtered views is an example of one of those higher level patterns. In fact, I've applied it to many different data sets in a lot of different domains, and it's a very good way of allowing you to do drill down into multidimensional data sets. I won't go into detail about what that graph is there. It's basically how you wire up the different queries to the views in order to be able to, in this case, there are a set of hotel visitors and cities that they came from and dates on which they visited. You can say, I'm just going to pick this hotel, show me the visitors there. And I'll select a subset of visitors. And in the calendar, just show me those visitors from the hotel that I selected. Think of Amazon, where you go on and you can do faceted filtering, where you select just certain ratings or certain brands and so on. And you kind of drill down step by step. This lets you do something a little bit more sophisticated. You can say, okay, I only want 4-star reviews. Now show me the brands that have 4-star reviews. I want to select from those. So you can actually filter every dimension on every other dimension, not just filter, in a sense, the full data set on the facet values that you want. And as a consequence, you can build much more nuanced and targeted questions about your data. So this is an example, and I like to include this because it's actually from one of the VASS challenges. The I think the last time I did one of those was in 2008. Right? So it's been quite some time. There was a synthetic data set of a made-up island between Florida and Cuba, and we were trying to figure out how suspected terrorists were entering the U.S. And we were looking at Coast Guard interdictions of migrant vessels to try to get a sense in space and over time about where and when they were trying to enter the country. And I believe in the scenario that they actually tried the east coast of Florida and the west coast of Florida, and then they actually tried to come into Belize or something like that. We built this visualization with the cross-filtering pattern, plus some additional interactive capability within the map to allow you to say for certain ships or certain times, certain sets of passengers and so on, what were the others, in the other dimensions, what were the other data values that might be worth looking at. So for instance, we could pick the passengers over there that were actually on 3 vessels that actually tried to get in 3 different times, look at the Coast Guard vessels that interdicted them, see the different vessels and where their interdictions and landings were on the map, see where it happened in time, and try to get a sense of the patterns of what was going on there. So some sophisticated multidimensional filtering capability happening there. One of the more interesting things about this particular visualization is happening in the map there. It'll come up in just a second, and you'll see something a little bit unusual in terms of interaction capabilities. It goes beyond basic brushing. So let's see, we'll get here just a second. I'm going to turn something on there, and you're seeing a very different kind of selector. You see that circle there with a little thing that looks like a crab a little bit? Right? Normally when you select things in a view, you have a lasso or you have a rubber band or you select individual items. This is trying to be a little bit smarter about that. It's letting you select a radius geographically. It's actually hard to do accurately. It's not geospatially accurate, but it's rough and it demonstrates the purpose. And it also lets you say, from the point that I'm pointing at any given time, show me the n closest interdictions or landings. So as you move the pointer around with your mouse, you're seeing up to a certain number of interdictions or landings, so long as they appear within the radius of that circle. And so it's basically a pay nearest neighbors within the radius query that's being performed interactively. Right? With the notion that, for instance, I'm interested in everything that happened up to a certain number of events with relation to a particular point in space. Right? That's a sophisticated query. You could certainly code that in to your visualizations using low-level code. And in fact, this is being done with a prototype extension of the coordinated queries language that lets you define the visual feedback of the interaction, the circle and the lines that are being drawn there, how it responds to the mouse and keyboard events, right? So kind of how it translates events into actual query interactions, and what its consequences are on the queries as well. So we're actually building in language to let you express how to map interactions into what you see for queries and what happens as a result of the queries. And this is a big part of what we need to do data editing. Just quickly, another example. This was also from the VASS 2008 challenge. This one happens to have animation. This is an evacuation scenario. One of the things that this is showing here is that we can actually perform animation and continue to interact, whether by panning and zooming or selecting paths. Later on, there's some lassoing of regions, selecting ranges of velocities to see only people who are moving at certain speeds or in certain directions, and so on. These are all being built by basically writing these little declarative language snippets and wiring the views up. This was, admittedly, I'm an expert in building visualizations in my own system, but this was only a couple of days of effort to put together this whole thing. And it's probably not more than a few thousand lines of declarative code. I'm going to skip a couple of these because there's no need, and I want to get to the main point. So this is one of my favorite visualizations. I like to show this one because it's a case where more or less everybody's a domain expert of sorts. This is data from the Internet Movie Database, movies, actors, genres, and so on. It happens to be data from about 2001 to 2007, I think it was. It was for an information visualization conference contest some years ago. What I'm doing here is I'm using a graph to express a query, what movies have Luke and Owen Wilson been in together? It's an easy query to state, easy question to state. Right? But how do you put together that query? I hope you're not going to do it using SQL, right? Or some other database language. Right? Here we do it by basically selecting items and turning on checkboxes. Basically, we put together a sequence of simple interactions to express the query. If you were following along with what was being done there, I'd selected Luke and Owen Wilson, and then was kind of looking at, I filtered out to show only the movies that one or both of them was in, and I was kind of watching the graph as I went along to see which ones were in together. So I select Luke Wilson there, made him show up in the graph, selected the two of them. They're brothers. You might think that they've been in a lot of movies together. We'll find out that that's not actually the case. I filtered the movies table to show only the movies that one or the other of them have been in. Started to connect up the graph so it would show edges for which movies each person had been in. Turned on these blobs that would like group together visually all the movies that anyone had been in. And I started selecting more movies, thinking that I would see an intersection between them. And when I selected all of them, admittedly they're just popular movies from 2001 to 2007. In fact, only the Royal Tenenbaums is the one that they've been in together. And that's the one in the intersection of the two blobs. So a complicated qualitative question that might be hard to express in a lot of systems, but we express them through simple clicks, and we can see the result visually. All right. Other examples. Let's get to the real meat. In the visualization community and also in digital humanities, we're still mostly looking at representation. We mostly develop ways to present information. In visual analytics, we spend a lot of time talking about process, which is good. But we still have to spend a lot of time talking about, yes, just about every visual analytics paper and every system has interaction in it. And we have to focus on that as something that we need to develop to provide us with greater analytic capability in our tools. Right? So what can we do to improve on that? We can ask two, I think, big questions about interactions. One, how does the way that we present our data visually affect how we can interact with it? Our visual representations have kind of a shape to them. Rectangles and circles and blobs and lines and so on. And each one of these kind of, in HCI parlance, they have affordances. They have a shape to them. There are ways you might interact with them. If you have a line, you might click the center of the line and drag it around. You might click an end and stretch it and so on. Many of these are the kind of things you might imagine in drawing tools, but maybe there are other things that you can do with them as well. So we're interacting through the visual representation of data to make some kind of change. And I'm going to say that these are actually changes that we should express in data. The second question is, how do we actually express our ideas as data through interaction? And this is a more complicated question than it might at first seem, because we're not just talking about how do we express data values. If there's an attribute value that's encoded as the length of the line or the center position of a square, then certainly we could drag the square around and supposedly we're changing the underlying data value that is being mapped into that center in the first place. But how can we actually express ideas about data? Ideas about relationships, about ordering of things, about logical relationships and dependencies. That's part of the big question. So we have many ways to encode individual data items as position, size, color, shape, texture, length, angle. We start to get into more obscure ones that are harder to incorporate in a way that's actually readable. But we also have ways to visually represent entire data collections. Right? We sometimes call these the visualizations. Sometimes we call them the views. But they're plots and graphs and tables and parallel coordinate plots and word clouds or tag clouds, word trees, cone trees. The list goes on and on and on. Some of them are well known and popular, and other ones are obscure. But the information visualization community still spends a lot of time trying to develop new techniques, new fundamental ways of visually representing a data collection in some kind of coordinate system, and coherently contained on the screen somewhere. We also have a number of ways to gesture, to navigate in these views. So we pan and zoom, right? Sometimes we can rotate, right? We can drag and stretch things around. If you have multi-touch, you can do things like pinch to zoom in a space and so on. We've got a lot of ways to interact with the space of the views itself, but we have relatively few ways to interact with the data items themselves, right? In visualization in a systematic way. So for instance, we can take a set of items in the view and we can lasso them to select them. Sometimes we can adjust individual values in widgets. Sometimes we can label items using a text box. This is what we usually think of as annotation. You select a bunch of items, you bring up a text box, you type in a little string. That string now is stored somewhere and it tags the individual data items, and you get to see that tag whenever you're seeing the item, supposedly. Just as it's marginalia, really, right? It's extra information that's off on the side. One of the things that we don't actually do is have those annotations be primary data in the system, right? It's an end, right? It's terminated. The data is not actually in the system. One of the things we want to be able to do is make it so that when you annotate, you're actually putting new data into the system, and then you can work at it. There are richer ways of interacting with data items, but they're typically application specific. So for instance, you can take an item and you can paint it with a color. This is actually very similar to annotating. Instead of associating a text label with something, you can go in and have a little color editor and say, I want this one to be red. And it remembers that it should be red. You can imagine attaching just about any data value or combination of data values that you want to individual data items or collections of data items. You could also drop a pin on a map, right? So this is Google Maps or a lot of the other map tools that are out there. You're basically building a little data set of locations whenever you do that. Drop a pin there, there's a latitude and longitude, it goes into a table. If you have a set of them for all the places you want to visit, you get a table of those. Right? So Google Maps does provide some visual editing capability directly within the visualization, but it's application specific. Right? We want to be able to generalize this, right? So that we can build it in to our various visualization tools quickly and in a way that accommodates the particular exploration or analysis needs of our users. So let's return to the first question. How does the visual representation of data affect how we can interact with it? There are a lot of visual characteristics, right? So you can see some there. We've got shape, we've got color, we've got some texture in the dashed outline of that flower, lollipop, whatever it is. We've got fonts and font styling and so on. There are a lot of different kind of visual channels, visual features of individual items, and every one of these is a possible thing that you could adjust interactively within a visual representation in order to change data. So we've got these data attributes, and we encode them as visual characteristics. This is just visual encoding that we know about well from visualization. Oh, wait, what's it doing? Okay, it went backwards, sorry. And then we render them into the actual graphical objects. So this is the normal forward part of visualization that we actually know pretty well. Now, I want to develop the backward step. So can we perform gestures that have a shape to them? They're shaping actions. And then interpret those shaping actions to actually decode them back into data attributes. We talk about visual encoding a lot, but how about decoding gestures? We have lassos, we have clicks, we have scrolling, and so on. Each one of these has a particular shape to them. It has translation, rotation. there's shape that we can extract graphical characteristics from. Right? So we have the form of the gesture. They have these graphical characteristics. The shape of the thing that we're manipulating, like the circle or the triangle there, kind of constrain the movements that we can perform in a sensible way. And the bounds of motion that we perform determine the possible changes to the data, but it doesn't have to be literal geometry. So for instance, I could take a circle that I have on a map where the size of the circle is encoding the population of an ancient city. And it's encoded as, say, the logarithm or some other sensible compressed scale of the size. And then I mouse over and use the scroll wheel. And what that scroll wheel is doing is actually changing the underlying population in a way that corresponds to the encoding. So say you scroll the wheel back by 1, it goes from 10,000 to 1,000. And of course, the item gets re-encoded to show that, and it gets shown as the 4-sized circle instead. So rather than going back to our spreadsheet and typing in 1,000 instead of 10,000, we've actually designed a gesture that allows us to edit the size of the city within the data set directly. We've built that data editing capability into our visualization tool. Similarly, you might have a primary food crop associated with the city that's being encoded as color. So for instance, you might have wheat as red and yellow as corn. It's just a categorical color scheme. You hover over the top of it, you press a character that's associated with the particular category. It changes that in the data, and then that propagates back through. It gets re-encoded to be shown as yellow. We can build this into our systems in a very systematic way. Now, I spent far too much time talking about all that preliminary interaction stuff. I've been actually thinking about how to fill the time and ask you to come up with a data editing interaction. I only have a few more slides after this. So I think what I'm going to do right now is just ask, can you think of an interaction like scrolling the wheel to adjust the population or hitting a character to change the primary food crop? Are there examples that you can think of in the visualization tool that you care about where you'd be able to edit the data directly by interacting with how it's shown in a particular view? Is there something you can think of? Okay. What would you do to, what would be the thing that's sort of,
so if you've got power in a remote location, set battery, and got the outside air temperature, discharge profile, then on the road, the happen, jet forward, and that was visualization to serve for.
okay. So you're setting for a particular item in the field off of the profile. Right. Right. And you can absolutely do that. The examples that I've shown are kind of like just directly editing particular data values. But you can have the gesture that you perform and the resulting values that you can reach by performing the gesture fall within some particular data model, some particular constraint. So for instance, you have a conservation profile, and the gesture kind of moves you up and down that curve and shows you a result. In fact, the scroll wheel example is doing that, right? The actual clicks are mapping into a logarithm scale. Now, we now have a new dimension for interaction design that we can do here. We're now going to design the gestures. In particular, we're going to design the effect that gestures have on data, and also the side effects of what happens during the gesture. So now, suddenly, something like a lasso, when you're performing that gesture, is something that is somehow changing the underlying data in a set of data items. We usually think of lasso as a way to highlight. Well, we are changing data. We're changing the one bit of data that we use to show whether it's highlighted or not. When that bit is on, the item is highlighted. When it's off, it's not highlighted. Selection, hopefully I can blow your minds a little bit. Selection is an annotation. Selection is one bit of annotation. It says on or off for my particular purposes. So all this time in our visualization design, when we're doing selection interactions, we've been working with the degenerate case. The degenerate case in which we can only turn things on and off. All the other possibilities of associating more than one bit with particular data items, we haven't been doing those. So there's a whole space of possibilities for basically injecting data through interaction back into our systems in a way that's more than just highlight it or not. This is all more than just literally drawing. Literal drawing is performing shaping actions to directly change the visual characteristics. But we're not doing that. We're going through the data attributes indirectly. But they don't need to have corresponding geometries. Right? With drawing, you're kind of literally changing the physical shape of something. With the scroll row, for instance, the geometry of the scroll is just being associated with the size of the circle. Right? We're not working in the same space in a sense. We do have to define the inverse function to say how the gesture changes the data, and it kind of should correspond to how the data is being encoded in some sort of sensible way. And we could go back to stuff from the 80s to have some knowledge for how to do that. At any rate, my research group and I, we're working on a declarative language for both doing encoding and decoding. Do I have a couple minutes left?
Yes.
Okay, good. Was I supposed to leave time for questions? Okay. That was the question. Here's the bigger question. Just a couple more slides here. How can we express our ideas as data? So we want to be able to express entities, to say there are things in this space. We want to be able to add and remove and to characterize by giving them characteristics through interaction. So we drag things on a map to adjust their location. On a timeline, we might nudge them to reorder them or to assign times to them, to say, no, this thing that I'm reading about, I'm a scholar, I think it actually happened at this time. Right? You change that point in the data. You pinch to associate an uncertainty with a measurement, and that uncertainty gets injected to your data as well and supposedly drawn somehow by people who are trying to figure out how to represent uncertainty, which is a hard thing. You can click and type to name or label or annotate something, of course. But part of this is that we're not just annotating anymore. Suddenly all the data is an annotation. We can express relationships. So draw or move or erase arrows to edit links between items. Press some modifier keys to group things together to say that they're all in the same set. Use the scroll wheel to classify items. Or draw a path to sequence a set of locations over time. For instance, a set of cities that somebody visited. If there are a set of cities on a map of Europe, and I want to know where Voltaire visited, and I've been reading a book, a whole collection of books and letters, I might say this one, this one, this one, this one, and that ordering is recorded in the data, and it's shown as a path, and that's suddenly a scholar interpreting their deep reading and injecting their conclusions back into the data. Getting even at an even higher level, can we express our comprehension of things? Can we express reasoning? Can we change the set of values in a column to record our collective observations? Create multiple columns to record alternate interpretations? Whether later on you say, oh, I want to look at my readings in a different way, following a different schema, or some other scholar has their own ideas about the ordering that Voltaire visited. Can we both record those in our data and kind of have competing hypotheses, as we sometimes say, about how that's happening? Can we then process that data as well and aggregate? And finally, can we share these things? So can we associate these annotations that we enter interactively with the times that we perform them, with the different people that perform them, and our analytic scholarly purposes of doing that? Can we say who can edit those columns and who can access them? Provide basically access control over recordings of interpretations. Can we define columns that adjudicate multiple interpretations? So I enter my opinions about where things happened. You enter your opinions about things happened. And then we have a column that kind of assembles the votes by some calculation. And then maybe that's the thing that we choose to actually show on the map. So that if I go in and change by editing my particular votes, we actually see a consensus view of the map or the timeline or whatever it is, plus our own individual view. But we can do this in a way that very cleanly integrates into the overall architecture of interactive visualization. You can take snapshots of entire columns to say, you know what, I want to remember that set of interpretations that I made, but today I'm going to think through my reading again and make a different set of interpretations. I want to remember that. I was going to have you do another exercise. I actually wish we had another hour. This would, I think, be a lot of fun to say, if you had, say, the movie data, what additional columns of information would you like to be able to record about the movies that you've seen, or the genres that you like, or the people? We could actually, if we had the right visualization, get you all to vote on movies and actors and genres and try to see what the consensus views are about whatever ideas that you have about movies. So here's kind of the summary. Don't let annotation be an endpoint. If we think of annotation as just writing in the margins, or adding a mark or drawing an arrow, we're kind of working in the analog space and thinking in the analog space. It's something that's just an overlay. It's not data, right? We've come out of the data world, and we're back into a world where the things are all not accessible to the computational system. Why on earth would we do that? We work so hard to get things into data and to be able to work with them in the first place. Let's not build our tools so that some of the capabilities are such that we immediately exit digital capabilities. In our tools, annotations are really data, right? When we write something, it's hand-formatted text. Symbols that we draw are actually showing quantities, arrows imply relationships, and so on. Let's find a way to make sure that when we're annotating, those things are actually being injected into a data. And if you think about it, all data is really annotation. This is the really broad view of things. Right? Every data item that exists because somebody observed something in the world and decided to write it down. Or they designed an instrument that makes particular assumptions about physical relationships in the world and use that to record data values. Regardless, it comes from us interpreting the world in some way. So all data is annotation, and in a way, we always start with a blank spreadsheet. Let's not think of our data sets as up on some pedestal as these beautiful pre-existing things that was there before we arrived, and now it's just our responsibility to look at it without questioning or possibly adding to or revisiting the values that are actually in the data. So the idea here is to ampliate. It's from an old word, Latin ampliare, meaning to enlarge or to extend what's already known. And it has a legal meaning as well. But it's this idea of having open-ended, interpretation-driven modification of data directly within visual representations. Right? So can we perform interaction in an open-ended, interactive way to do all of these things that we want to do in scholarship, in the case of the humanities, or analytics, in the case of our many, many fields that we hope to support through visual analytics. So let's modify this interaction loop just a little bit to let us gesture and edit data as part of the cycle of visualization. Thank you.
Thank you, Chris. Well, we have time for a question or two, maybe.
Absolutely.
Great. Let me just find the microphone, Craig.
All right.
Do we have one? Great. One, two.
Thanks, Chris, for a great talk. I think I first met you about a decade ago, that's when I first saw Amplify, and I think I've been astounded by how the quality of that system has been compared to other systems over the years. You made a comment during your talk saying that if you wanted this high interaction capabilities, that you should develop a system with desktops. But as we have seen through the InfoVis toolkits and the applications and stuff that have been built recently, we're more tending towards the web. And I think your system should definitely have got more publicity in the InfoVis community, but it hasn't, unfortunately, because I think the things you've done are awesome, but they've been more leveraged towards the web. So my question is, what do we need to do from your perspective, since you've been building these tools for a long time, what do we need to do in order to get our interaction capabilities on the web?
Right. So it's a difficult problem, and I've tasked a number of students with trying to to study it. Part of the issue is that in a highly interactive visualization system like this, where the queries are pretty complicated, lag time is really important. For instance, in that sports visualization, being able to drag the window and seeing everything else update, it's really important that you can actually see how things are changing, that motion parallax idea over time. And so the lag time on the web is really quite important. Right? And as much as we would like to have 20 milliseconds, in fact, you have to get those packets over the web. The server actually has to still do whatever it's doing, and hopefully the server is higher performance, and deliver it back. We just haven't seen the interaction speed that we would like. Right? That old 100 millisecond rule for interactive immediacy is actually really hard to achieve in many cases. To answer your question a little bit more forward thinking, I'm going to be on sabbatical next year, and I'm developing Improvise 2, which is going to be called something else. But we're going to build in a lot of these data editing capabilities. But also we're going to split Improvise into a client-server model that runs server-side Java. When it runs on the desktop, the builder interface and the browser interface will all be glued directly on top. So that it basically just behaves like a desktop interface. But the server one will also be standalone. And we're hoping to write JavaScript libraries. It won't be D3, it won't be Vega, but it'll be a very similar style of JavaScript that will let you send back these coordinated queries and these data editing specifications back to the server and then deliver up sets of images and results that you can then embed in the browser. So we're going to try to re-architect the system in a way that actually does support web development as well. But even with that, I don't expect to be able to achieve the interactive immediacy that was preferred for many kinds of interaction. If you've lassoed a set of items and you're scrolling the score wheel to change the population, and you're kind of watching as it happens because you want to basically express the information that you're seeing and trying to put into your data, we kind of wanted that to happen pretty quickly. And you want to see as your scroll wheel is happening, and you don't want to scroll the scroll wheel and it goes very slowly. It's hard to, you might be able to achieve that for particular interactions by custom tuning your system, but being able to do it in a general way in a system architecture is a lot harder to do.
Okay, Chris, you may remember from in 2010, you might have a whiskey tumbler on your somewhere in your house.
No, in fact, I don't, because I only brought a carry-on bag last time too.
Ah, okay. So, well, we have one of these for you now. So maybe we need to post this to you.
Maybe yes.
Yeah.
Either that, or I have to try to sneak it past the TSA, and they don't like that sort of thing.
Thanks very much.
Thank you.